There are places in this universe where matter is punished so brutally that the idea of solid stops meaning anything at all. Places where a mountain could be compressed into a grain, where a star dies and what remains is not fire but pressure, pure, merciless pressure. And if you could somehow stand near one of these objects for even a moment, you would discover something deeply unsettling. The universe does not merely contain strange things. It contains realms where the laws that make human life feel stable begin to collapse into something colder, darker, and almost impossible to emotionally accept. Because density sounds abstract. It sounds like a number, a textbook word. But density is really a measure of how much reality can be forced into how little space. It is what happens when gravity keeps winning, when atoms lose their comfortable distances, when matter is squeezed past the point where everyday intuition can follow, and out there, scattered through the dark, are the most unforgiving examples we have ever found, the densest objects in the universe, the final ruins of stars, the places where nature reveals just how violent existence can become when nothing is left to resist the crush. On Earth, we live inside a gentle compromise. Our bones hold shape, steel keeps its form, mountains seem eternal. Even the core of our planet, under immense pressure, still belongs to a world our minds can picture. But that sense of solidity is provincial, local, almost naive, because the cosmos builds objects that make Earth feel airy by comparison. It builds stellar corpses so compact that the matter inside them no longer behaves like matter in any familiar human sense. The first step into this abyss is the white dwarf. It begins with a star not too different from our Sun. For billions of years it burns calmly, balancing outward heat against inward gravity. But balance is temporary. Eventually the fuel runs low. The outer layers drift away into space, and what remains is the core, small, exposed, unimaginably compressed. A white dwarf is roughly Earth-sized, yet it can contain a significant fraction of a star's original mass. Not a glowing giant anymore, just a stellar heart left behind after the rest of the star has been stripped away. That alone should feel disturbing. Imagine taking something with the mass of a star and forcing it into a volume comparable to a planet, not by engineering, not by design, but by the slow, inevitable failure of nuclear fire. A white dwarf is what happens when gravity almost wins completely, but not quite. The atoms inside are packed so tightly that the star is held up by a quantum rule, a kind of final resistance built into nature itself. Not flames, not pressure from fusion, just the refusal of electrons to be squeezed into the same state. A dead star surviving on a technicality. And even here the numbers begin to turn against intuition. The matter in a white dwarf is so dense that a small amount would weigh tons on Earth. Not a truck, not a building. Tons. In something you could hold in a spoon. That is the first emotional rupture in this story. The realization that the universe can take the familiar ingredients of a star and rearrange them into something that feels less like matter and more like a verdict. Yet white dwarfs are only the gentle warning, because if the original star is more massive, gravity does not stop there. The collapse continues, past the limits of ordinary atoms, past the quiet dignity of a white dwarf. It drives inward with such force that electrons and protons are crushed together. The empty architecture inside atoms disappears. Matter is forced into a more brutal state. The star implodes, explodes, and what is left behind is a neutron star. A neutron star is usually only about 20 kilometers across, a city-sized object, a sphere so small, compared with the star that made it, that it seems almost insulting. And yet inside that tiny volume can be more mass than the sun, more than 100,000 Earths. Sometimes nearly twice the Sun's mass, crowded into a ball you could drive around in less than a day. This is no longer just dense. It is matter pushed toward the density of an atomic nucleus, a gigantic nucleus hanging in space. To understand how extreme that is, you have to let go of every visual instinct you have. A cubic centimeter of neutron star matter could outweigh Mount Everest. Not a cube the size of a house, not a slab, a cube the size of a sugar lump, smaller than a child's toy block. And it would outweigh a mountain. The human brain can repeat that sentence. It cannot truly absorb it. There is a difference, and that difference is where cosmic fear begins. Because a neutron star is not simply heavy, it is oppressive. Its gravity is so intense that if you fell toward it, the difference in pull between your feet and your head would become catastrophic long before you arrived. The surface itself is not some glowing ocean you could imagine touching. It is more like a boundary between our kind of reality and a harsher version of it. A place where ordinary matter has been humiliated into something smaller, denser, and far less forgiving. And still, even this is not the full horror. Neutron stars spin. Some rotate with astonishing speed, sending beams of radiation across space like cosmic lighthouses. Others carry magnetic fields so strong they would wreck matter at a distance we struggle to picture. They are not peaceful remnants. They are active ruins, dense enough to bend comprehension, violent enough to scar their surroundings, and stable only in the way a loaded trap is stable. What makes them so haunting is that they are not fantasy. They are real consequences of stellar death. This is what nature does by itself in the dark. It takes a star, strips away its softness, and leaves behind an object that feels less like a destination and more like a warning. Somewhere in our galaxy, there are neutron stars moving silently through the night, each one carrying a density so extreme it approaches the limits of what matter can endure without disappearing into something worse. And there is something worse. Because even neutron stars may not survive if too much mass is forced into too little space, there comes a threshold, somewhere beyond what neutron pressure can support, where gravity stops negotiating. No quantum resistance, no known structure, no final arrangement of matter that can hold the collapse back. The core keeps falling inward, and the universe responds by creating the darkest object we know, a black hole. This is where the language of density becomes dangerous, because black holes do not simply continue the pattern, they break it. According to general relativity, the mass collapses into a singularity, a point of zero volume and effectively infinite density hidden behind an event horizon. A boundary in space-time where escape velocity exceeds the speed of light. Cross it, and the universe removes you from the rest of creation. No signal returns. No story comes back out. There is something uniquely chilling about that. A white dwarf is compact. A neutron star is crushing. But a black hole is different. It is not just an object. It is a region where our current descriptions of reality stop feeling complete. A place where gravity does not merely dominate matter. It overwhelms information, light, direction, and any ordinary sense of inside or outside. It is density taken to a limit so severe that space and time themselves begin to behave like materials under stress. And yet, as if the universe enjoys making all of this even stranger, black holes contain a paradox. The bigger they become, the lower their average density can be. A supermassive black hole with 1 billion times the mass of the Sun can have an average density only about 20 times that of air. That sounds absurd, almost like a mistake. How can one of the most extreme things in the universe be, on average, less dense than a white dwarf, less dense than a neutron star, not even remotely close to solid metal? Because black holes are not dense in the way a rock is dense. Their mass is spread across an event horizon that grows with size. The larger the black hole, the larger the sphere that defines it. So the average density drops, even while the central mystery becomes more severe. It is one of the cruelest lessons in astrophysics. The closer you look, the less the word dense behaves the way you expect. Reality is not obligated to preserve your intuition. It is only obligated to remain real. This matters emotionally because it means the universe is not just extreme. It is counterintuitive at its foundations. The deepest truths are not bigger versions of everyday experience. They are betrayals of it. The densest objects in the cosmos are not simply heavy stones in the sky. They are endings, thresholds, the last states of matter before description gives way to uncertainty. And uncertainty is part of the story. We say singularity, but that word may really be a confession. It may be the place where our theories run out. General relativity points toward infinite density. Quantum physics resists infinities. Somewhere inside a black hole, our best frameworks disagree, and the universe keeps its answer hidden. That should unsettle us more than it often does. We have mapped galaxies, photographed black hole shadows, measured the depths of stars, and still there are places where reality remains sealed. Imagine what that says about our species. We are fragile creatures on the surface of a small rocky world, wrapped in a thin atmosphere, warmed by a very ordinary star. Every instinct we have was shaped by forests, coastlines, storms, hunger, shelter, touch. Nothing in human evolution prepared us to emotionally process an object with the mass of a star packed into a city or a collapsed region of space-time from which even light cannot leave. And yet we found them, we named them, we built the mathematics to glimpse them from impossibly far away. That may be the most moving part of this story. Not the density itself, not the violence, but the fact that minds as temporary as ours can look into a universe this indifferent and still ask honest questions about it. We cannot survive near these objects. We cannot touch them. We may never fully understand what lies at the center of a black hole. Physics itself may place hard limits on how close knowledge can get. And still, across generations, we keep trying. We send telescopes upward. We listen for pulses from neutron stars. We watch matter whirl into darkness. We pull meaning from light that began its journey before human civilization existed. The densest objects in the universe remind us that existence is not built for comfort. Most of reality is not hospitable. It is not scaled to human need. It is pressure without mercy, distance without concern, and time measured in spans that make civilizations look like sparks. A white dwarf tells us that stars can die and leave behind compressed ghosts. A neutron star tells us that matter can be driven to the edge of atomic collapse. A black hole tells us that there may be regions of the cosmos where all our familiar language begins to fail. And yet none of this makes the universe meaningless. If anything, it does the opposite. Because against that backdrop, Earth becomes more precious. Warm oceans become stranger.